Hi guys, how are you? Today I'm gonna guide you how to create a microservice application using WebSocket. We'll create a backend application using Spring Boot with support to the WebSocket. After doing that, we'll also create one front-end application that will be able to connect to our backend through WebSocket protocol. So we'll have the client A, client B, both are connected to our backend here, and we'll be able to send a message from client A that will go through our backend, and the backend will push that information to the client B. This is the nice about WebSocket. Once that we have the communication established between a client and a server, the server is able to push information to that client. Right? So client just keeping listening for data come through WebSocket. It's different that if a client needed to implement some kinds of REST calls where they call our endpoint in our backend, wait for the response, and to keep running. In this case, not. We have two connections established between the client and our backend, and the backend can push information directly to our clients. After we implement this part of the tutorial, we'll make one very important improvement here, that just in case we'll have to implement the solution in production, usually we'll deploy your backend in a cloud environment using Docker, using Kubernetes, in the AWS, I don't know, no matter, but it's important to notice that this instance of your backend service here, we can have multiple instances running at the same time when in production. So if we have more than one instance running, a second instance here, let me draw second line here. We have the instance 1 and instance 2 running together in the cloud environment. This leads us to a problem in the basic scenario. The problem is the WebSocket connection is made directly to one service. So even if you have a load balancer in front of the requests, no matter a proxy, the connection established always with one service. So we can have a situation where the client B made a connection straight to the service 2. In this case, if the client A tried to send a message to the client B, our backend service using a basic implementation could not reach the client B, just because it even don't know that the client B exists, because the connection is made with other instance of the service. How we can handle that situation of multiple services running at the same time in the clouds, and even with that situation allow both clients to communication? We need to integrate this solution, our backend solution, with a new piece of technology that is a message broker. We can add a message broker in the solution, and as a message broker we can use ActiveMQ, for example, and we can integrate your backend to connect in that broker and delegate the management of the session to the message broker. So for our application, for our backend application, it's transparent. You do not need to create so much code to handle with that situation. But once that we have this message broker in our architecture, what you'll be able to do is when our backend 1 try to send a message to the user B, they wish, because the message will be sent to a message broker, and the message broker under the rules will do the magic and to the service to push the message to the client B. Okay, so this is what we will do in the code today. Okay, let's jump to the code now. We will create a small web service application using Spring and with a basic REST endpoint, and after that we will add some WebSocket support to make some tests. So once that we have the Spring initializer open, let's create a default application here. Our default package will call of example.websocket. We can call this application of just WebSocket. This will be a demo for WebSocket. And I will remove this double WebSocket name here in the package. Now there is some dependence that we need to add here as a default. Let's add the web support, WebSocket. We also add the security. Oh, I chose wrong here. Security. And also Lombok to help us log and add some stuff there. Once we have that, let's generate the package. Will be downloaded here. I will just uncompress this package inside my project. I will open my project folder here. Just drag and drop the project. It's here. And now I will open the IntelliJ inside this new project. Let me choose here the correct one. It's WebSocket, and we'll be open the Maven project inside this new project. It is open here in the new monitor. Okay, so here we are with a very basic structure for our project. We have the default attribute here, default dependence here, and what we need to do here in additional is rename the application.prepared to a YAML file. I think it's better to do the configuration in the YAML file. I added some server ports because I want to run this application in the 8181 port and not the default one. What I will do now is create a REST controller just to test our application, and during this tutorial I will copy and paste some code inside here just to not take so much time to show you how it's work, and all the code that we use will be available in my GitHub. You can find the description here in this video, in the description, or what else. So we are creating the REST message controller. This will be a REST controller. I'll add here the log4j supporting for logging. It will be a let's create the method first. Send message, and we also add here a toUser. We won't be using now, but will be useful in the future. I'll just copy and paste the log information here, and this will be the body of the post. So we add the request body, and here will be the path variable, and this method will be a post mapping, and we can use here the path that will be v1 to user. Okay, I think it's enough for this first REST controller. It's something that we can start the application and try to see what will happen. Let's open here and see what happens. Okay, it's supposed to start, everything's okay. Okay, application is starting running. What we can do now is, I have a Postman here open with a collection empty, is WebSocket. We will create a post request, send message. Will be a post in the local host 8181. We can add a body that will be hello, and we will also add the v1, the one-to user ID. Let's use the WebSocket 8181. It could be everything that we want. I just standardize here. Okay, it's not authorized because we added a dependency here that is web security. So if you also try to open a web browser, I open one incognito here. I think it's here. Localhost 8181. You'll see a login page. What you do now, we don't need this level of authentication here. Let's just add one configuration inside our project to disable this type of authentication. To disable that, we can create a web security config in here. I will copy and paste some information. First will be the necessary notation, will be a configuration with enable web security. And we will override the configure method because we will need to extend the web security configure adapter. So here basically we add the configuration to allow every request in whatever is the path that we choose. So let's restart here our application and see what's happened. It's just restarting. While it's starting, we are open here. It started and let's send. Let's see what's happened. Okay, we have 200 as response, it's okay. If we take a look in the log file, we can see REST send message hello to user XX8181. That will be the log that we put here. This just means that our application is running up and we can file a REST request inside that. Until now, we don't have anything about WebSocket, just the dependency inside the POM. So now it's the time that we can start to add the WebSocket support. Let's close all this information here. The first thing that we need to do is add a configuration to configure the WebSocket inside our application. We will do that just creating a WebSocket config here, and I will copy and paste some more code inside this class. Basically, I will copy and paste the annotation that will be necessary, be a configuration. We will enable the WebSocket message broker and also a log4j here. And this class will extend another one that we will need to implement some methods. And now that came the configuration. First, we will override the register stomp endpoint. Here is the endpoint that our client application will connect to our backend through WebSocket. We will enable the with socket.js. This will allow the library.js from the client side make connection with our website or with our microservice. And another override method that we use will be the configure message broker. This is where message will be put in a topic and a prefix for our connection. In addition to that, I would like to introduce one piece of code that I think it's important. That is when the client try to make the first connection through WebSocket, I want to intercept this connection and perform some kind of validation. It's where we can, for example, check if the user is correct or make some kind of authentication. So we will create an interceptor and register this interceptor inside this WebSocket, and it will be possible to intercept this first connection. So let's create a class here. It will be called WebSocket interceptor, channel interceptor. I will again copy and paste some code here. Here will be a service with log support. It will implement also a new class, channel intercept. And now, more than that, I will copy a big piece of code here, but it's not so much different. It's not a big deal. It's just to take time. What this code is doing, basically, I override the pre-send method. That is before the connection between the client and server be established. This class will intercept this connection, and we can read some headers, body, and do whatever we want to do. If you have a system to authentication, we can just check if the user and password, for example, is valid. You can do anything that you want with this interceptor. So here I'm just reading the headers that came from my client, and I'm creating a user that will be returned for the client that made this request. And also I'm logging some information. And to register this information inside your configuration, we will need to override other method here. Basically, we will need to authorize this WebSocket channel interceptor. And we also need to override inbound channel method here. So basically we are made a registration of this intercept inside the configuration. Okay, this step is done. I've made the necessary configuration to run. Now what we'll do is test if the connection are being done correctly with your backend. However, to do that, we need to create a small front-end application. It's just a piece of code with HTML and JavaScript where we can put some information, click and connect, and establish a connection with our backend. That's what we'll do now. You can see here that you have a static folder. I will copy and paste some files inside and show you the JavaScript and what they do. I will copy here some files. Basically, we have a CSS file just to render correctly the HTML. A HTML with some fields, nothing so much here, just fields to type information. But what is most important here is the JavaScript file. Because inside this JavaScript, you have some functions that will be used to establish the connection with the backend. And what is important here is the connection function. Basically, we get some information from the form inside the HTML, and we create a socket.js object point to the WS register endpoint that is configured inside your backend here. Let me show you. WebSocket config. We have the register endpoint here. In addition to that, we also have the connection function that is called from the stomp object, where you are passing two headers, one auth key and one ID. The auth key, we are doing nothing with that information inside your backend, but it's just to show you how you can pass information through headers. That could be one type of key to make authorization in your backend or any kind of proxies that you have in front, API gateway or whatever. And after that, we have a subscribe into the topic that we defined also here in the config. We have a topic here, a configuration. Okay, so we have the connection function that establishes the connection, passing some information for the backend. We also have a send message, a send private message here that we will use later. Okay, also that we have that configured here. Let's start our application again, and let's see if the connection is working correctly. So I close this web browser here. Okay, it started. Let's open an incognito window. Once that we have the application up and running, if we type localhost 8181, it's supposed to show the page. Let me just open this web browser again, because I think I forgot one more things to do. I will open a new incognito window here, and to make this HTML fully work, you can see here that in the header we have some JS files being referenced, and to this file works, we'll need to add some dependencies inside the POM, and basically is dependence to WebJar. I'll copy and paste the dependency here in my POM file. Basically our dependency for Bootstrap WebJar. We have the jQuery support, the stomp support, and so on. This will be important for the web page works. I just have to refresh the POM here. And just restart the application again. And the application will run, and we can open incognito browser again, just to refresh. Let's see if the application is running. It's okay, it's running. Again, localhost 8181. We can see here the HTML. Basically we have the auth key. As I said, we are using this information for anything inside your web backend application, but we can use to do some kind of authentication. The WebSocket ID is a unique ID that you can provide for the backend. For the backend, identify the WebSocket connection. This is something that you can generate in the back end, but just for the sake of the example, I'm sending this information through the front end. So I will choose WS 8181, could be anything that we want, and file connection. Okay, here we go. So we have a connected status. This means that the connection worked. So we have a WebSocket connected between our client and our backend. If we take a look here in the console, we can see one piece of log information that is user with auth key ABC, ID 8181, section blah blah blah, connect and generate the user password object that will choose. So this information is in our interceptor. It is here. Let me show you in debug mode. I'll just close the application. You see that automatically the front end detects that there is no more connection between the client and the server. I open in debug mode. Add a breakpoint here. I'm just make a connection again, and you can see now that between this connection be returned to the client, we have it intercepted for our backend. It is in the connect status, so we can read some headers that will pass through this connection. Here we could perform some type of authorization, but I'm just creating one object, user password authentication token, and logging the information and return it back to the client. So we have here again a connected state. So we just could validate that the connection is working. Now is the time that we can implement the communication between these users. Now that we have the connection working, it's time to create a controller just to allow one front end send message to our backend through this new controller, not calling a REST endpoint, but send information through this WebSocket connection. So I will just shut down here application, close all this information, and I will create a new class here. It will be called WebSocket controller. WebSocket controller. I will just copy and paste some code here. Basically, I will copy and paste some annotations with log4j2. This has controller will be a method of posting that I'll copy and paste here. I will show you what is done. Just comment this for a while. Okay, what we have here, basically we have a WebSocket controller. It's a little bit different from the controller that we call through REST endpoint, because it's not a REST call, but this information will come through a WebSocket connection. So we have the method. A principal is one information that Spring inject automatically to you inside the signature of this method. It basically has the information of the user that was logged in the front end. So you can see here information like the username or the user ID, for example. It's the more important. So we are receiving here an auth key that we also, again, we could use to do some kind of authorization or authentication in a proxy. We have a toUser in the path variable and a message as a body. So once that we have that, We won't test that yet because we needed to add a service, a WebSocket service. The WebSocket service will be the piece of code responsible to send the information through WebSocket to other users that are connected. Basically, they use the Spring WebSocket framework to do that. So we will need to create a WebSocket service here. Again, I will just copy and paste some piece of code, starting with some annotation in the header, and basically the body will be like that. I will just explain to you what it's doing. We have here a simple message template that is one class from the Spring framework, the WebSocket support. Is that class that will handle the information that we need and send information to other clients. We have some method here, a notify user and send. Basically what I'm doing here is just receiving the user ID, that will be the identification that user provided during his first connect to our backend, and a message. The important line here is the 22 line, where you say convert and send to user. Send to user ID, the information that you put in this variable here, will be a JSON, and add this information in a topic. This will be the most important line in the code because it's that line that will be responsible to send information back and forth to different connected users. What we can do now basically is inject this class here in our WebSocket controller. And uncomment this line of code. Okay, so we have done our WebSocket controller. Is the class responsible to receive information from our clients through WebSocket and redirect this information to other clients connected that will be identified by the toUser value here. What we can do now is start application again. I like to open a new incognito web browser always, just to make sure that the code that is being loading from the browser is fresh and not came from any cache. Okay, we have the application up and running here. Let's fill some information here. The auth key, we can choose anything, ABC. The WebSocket ID is important here. It will be the identifier for these clients that are being connecting to the backend. So we'll choose S8181. We'll establish the connection. We can see here that as a username return, we return the same WebSocket ID that we provide. This is done in the interceptor. It's good to know that here in the interceptor, when we return a user to the front end, we are putting as a username the same WebSocket ID that the client send as WebSocket ID. It could be anything, but I'm just reusing the information. And now came the important part. I will send a message to the user ID 8181, and the message will be hello from 8181. Send. Okay, take a look here. What happens? Basically, this information was sent to the backend through WebSocket. The backend just push that information to the same client, and it was showed here. If we go to our controller and put a breakpoint here, I have to start again in the debug mode. We lost the connection. I will need to connection again too, just to make sure it's up and running. Okay, it starts. I'll make the connection again with the same information. It's connected. I will send the hello again. And now our WebSocket controller was breaked. So this means that that information arrived in our backend. We will send that we'll pass this information for our service that you call the send user and put the message in the message broker. But the message broker here is just in memory. We are not using any external message broker. Okay, so I will just play here, and here we have the same information again. What I can show to you now is how to make two application communication. So we'll open another browser here. And we will establish a new connection, 1, 2, 3. This will be the WS81B. We are connect with a new ID. So I will send one message to myself here just to make sure it's working. Hello from 8181B. Oh, it's I had one breakpoint here just to follow. Okay, we have a message here. It's very teeny, but it's arrived. Now, what I will do now here is inside the client B that I have connect, I want to send a message to the client A. So I will just copy and paste the ID from this client. I will put this ID here as a destination and send the hello from B from here. Okay, we have here the message arrived, the message came from one client to other. So here I will do the same. I will send a message to B and hi. If I go to the client B, I have the information here. So it worked. Basically, we have two separate clients connected in our backend, and we can make information. We can send information from one to other through WebSocket. What I can show to you now is one problem, that for this test we have just one instance of the backend running. So these two clients are connected to the same backend, to the same application running. And if we have two applications running with different clients connected to them, they won't be possible to communicate to each other because they are running and managing WebSocket section in memory. So we need to add an external broker in this architecture. I will just show to you that won't work. So basically what I will do now is duplicate this running here. We'll call this one of 8282, and after doing that we are add some VM option here, and we will add some I will copy and paste this information, it will be better. Basically we will change the port of the application to 8282. I'm just setting the server port here, and this will replace this information here for 8282. So I will open the first application that will be running in the 8181, and I also will open a second instance of this application inside the 8282. Just give a play here too, and we'll now have the two applications running. So what I will do now first is close my incognito browsers again, and I will open again. So now what I'll do, I will connect one client to 8181 and another one to 8282. So we have two services running in the backend, and each one of these clients are connected through WebSocket to one of these services. So as of key ABC, for the first client I will call SS8181, I will connect. It is connected here. I will do the same for the other client, ABC. As a WebSocket ID, we'll call of this client as 8282. I will connect. It's connected. I will send a message to myself here to 8282. Hi from 8282. You can see that it's arrived here. If I send a message to myself to 8181, hello from 8181, it also arrived here. However, if from 8181 I try to send a message to 8282, take a look here, we have no errors, of course, but the message does not arrive in the second client. That's the problem, because we have a separate instance of the backend, customer connecting in one of them, both. However, the WebSocket section are not managed centrally. This is the problem that we have here. So if you have the situation that the backend needs to push information to the clients, we can lead to a situation where the client does not receive that information. That's the reason that we need to add one extra message blocker here. Okay, what we will do now is run a local version of ActiveMQ as a message broker. We use Docker and Docker Compose to do that, and connect our application to this message broker. So first we'll go to our application. We'll create a new file here that will be broker compose YAML. I will copy and paste some information, that is the composer to use the image of ActiveMQ Artemis. You are setting up the username and password and exposing some parts inside. Once that we have that, we can go to our console and go to the project folder and run docker compose f broker YAML up mq. This will run the Artemis message broker in your machine. Once that is up and running, to see if it's working, you can access the 8161 part. It needs to show the ActiveMQ page. If you go to the management console and type Artemis, you can see the application running here. Just you see that it is up and running. So we'll have now one message broker running. What you need to do is integrate your application to this message broker. How will you do that? Basically, it's not a big deal. You have to use the WebSocket config here. Again, I will open the application too. Again, I will also copy and paste some code here just to make things more fast. Basically, what I'll do is put in your YAML application some information regarding to where this message broker are. Basically, that the message broker is running the local host, the username and password is Artemis, and the part that are exposed. So once that we have that, we can go to our configuration, and I'll just read that information from the config file here. So basically, I'm putting inside attributes from this class the values that is in our application, and the main difference will be here in this method. It is where we need to configure the connection with the message broker. So I'll comment this line and put this one here. It's the same registry that I'm using here. Let me just show you. What I'm doing here is, rather than use enable simple broker, I now use enable stomp broker relay. And in addition to use this new method, I pass more information to this object, that is the host, the port, the user, the password, all the information, and some additional topics that will be used if the client won't be detected. The message broker will handle this information to other topic to deliver to the correct user. So once that I have that, it's supposed to work. So let's open the application again. The integration is done. Let's see if it's nothing bad happens here. Okay, we have a problem. Okay, we need one more dependency inside your pawn class. So let's fix that. What we need to do here is to add two more dependencies in our pawn. We need to put here in our pawn the net reactor and the net reactor core. I have the dependencies here. Let's just copy and paste inside our pawn. Net reactor, reactor net, and reactor net core. So let's build and open the application again. These two dems are required to run the application connecting to the message broker. So the application is starting now. Okay, it started. So we can close that one. And what we will do now is open the same two applications. I started the 8181 service, now I will start the 8282. And we'll keeping open two microservices, one in each port. However, both microservices are connected to the same message broker. We will perform the same task that we did before, however now with the ActiveMQ in place. Okay, both applications are up and running. What you do now is just reload the connection to the 8181 and 8282. Let's perform the connection again. The WebSocket ID of this side will be 8181. I will connect. It is connect. Take a look here. Now in the connection response, we can see that the response say that we are connected with ActiveMQ Artemis. So we'll do the same for the other microservice, 8282, connecting. Now came the funny part. If we send a message to ourselves, hello from 8181, okay, we receive here. I will do the same in the other side. Send a message as user destination 8282. hello from 8282, send the message here. And what I can do now is from the clients that are connected to the second web service, a microservice, we can send as 8181 destination, not here, but it's here. I will send, and you can see in the other service that we received the message. And here I can do the same. From the 8181 client, I can send as a destination 8282, and we can see here that the other application received the message. This shows that putting one ActiveMQ message broker in this solution make that even if we have two instances of the microservice running with a WebSocket connection in each one, they could communication to each other, passing the message through this microservice. This is very good because if you have a solution in the cloud and your application just scale out with multiple services running, this will certainly happens. One thing that we can do now that we have the ActiveMQ in place is just make a little change in that controller, REST controller that we did, and if we can just try to make a request in this controller and send this one message through WebSocket through one of the clients. What we can do here is just inject the service, the WebSocket service, and once that we have the service here, we can call the notify user, passing through the parameter, the to user, and the message here. So we have a REST endpoint in this case that will send a notification through WebSocket for one of the clients that are connected, and that is identified by this to user here. As I made a change here, I needed to close one of the servers and just starting again. And while it's starting, we can take a look in our Postman here. Okay, I have the request in place. The service just started right now. 8181, it's here. I can connect again. Yeah, okay, it's here. Let's see if it's working now. I'll fire a request to the service 8181 and try to send a message to the user 8282. However, this time it will be a hello from the REST endpoint. So here we have the 8282 client. It is connected. Let's see what's happened. Okay, we have successful here, and now we can see that the message just arrived in the client. This means that even a request that came to our service through a REST endpoint, we deliver the message through WebSocket. We just push that message to the client that is identified with this ID. One last thing that I would like to show you how to do in this example is how to detect when a client connects in your service and also disconnect, because we have an interceptor that can intercept the connection request from a client and perform some kinds of authorization or authentication. But after the connection be established, we also can detect that is connected with successful, and we also can detect when it disconnects. This sometimes can be useful if you want to manage when a client is connected and disconnecting, and if it records some information in the database, manages how many clients are connecting your backends and so on. So let's do that now. What we need to do now is stop our service and create a handler to handle the connect and to handle the disconnect. So let's create two classes here. We'll call WebSocket Connect Handler. Let's just name here connected. Handler, and also other class that WebSocket disconnect handler. WebSocket disconnect handler. Again, just do a fixed typo here. Okay. In the connect handler, we have here the connect handler. I'll copy and paste some code inside. Here in this class we have, I will copy the whole class here to show you. Basically this class, you implement an application listener, and every time that a customer was connected with successful in your backend, this class will be fired, and we can detect on application event that the user are connecting, and what we will do here is just log some information. User, the name of the user, that will be the ID that we are using. Connect to the section ID. This is the section that was created automatically when the client is connected with your backend. So this class is responsible to detect when clients are connecting, the same that we'll do with the disconnection one. I'll also copy and paste the code here. It will perform the same way every time that the client disconnects, and a disconnect can happen for many ways. If you lose the internet connection or the network is broken, will automatically be disconnected from the backend. It's something that could happen, and if this happens, the client needs to connect again. The client needs to keep control of if he is connected or not. So we can detect that on the backend side and perform some action like remove this user from the database or from some table if you are just records when a clients are connecting and disconnecting. You perform some kind of control. In addition to that, we also need to create a configuration. So we'll just create one class here that will be the WebSocket handler config, and again I'll copy and paste the information here. Basically, just import this section, will be from the Spring. Okay, basically what we're doing here is just register these two handlers are connecting, disconnecting for our WebSocket. Now I'll just open the 8181 application again. I will just let me open here in debug mode, just be better to show you. Okay, it's starting. Okay, just start. Let's just clean the log file here. And okay, here we have the web front-end application. I will just reload, and now I will make a connection. ABC 123 connect. Let's take a look in the log. Okay, once that I did perform a connect, we have two important logs here. The first one, user with auth key ABC blah blah blah, was the log from the channel interceptor. This was what received before the connection happens. That's where we could perform some authorization. But the second one, the WebSocket connection handler, is the log that was performed after the connection be established. So here we are sure that the client made the connection with our backend. So we could perform some actions like record that in the database that this user just are connected. Okay, so in the same way, what you do now is just close the browser. Let's see what's happened in our backend. Take a look here. WebSocket disconnection handler was triggered and user 123 disconnect from blah blah blah. So this happened that this shows us that when the connection was broken with the backend, your backend could detect that, and again we can perform action based on this. So guys, I think that we did here a good example of how to use WebSocket with Spring application, and also use one ActiveMQ broker to manage the sections, and we can handle that situation where we have more than one server running, and even if you have scaling our backend server, we can keeping communication between these clients. All this code is available on my GitHub. You can use as you can. And if you have any doubts or any comments, feel free to contact me. So guys, thanks so much to watch this video, and see you next time. Bye bye.